Hello everyone, good evening, and welcome to the OneClass channel. My name is Fajiri Rome, and I'm an Honors Bachelor of Science graduate working towards medical school at the moment. Today we're going over some commonly asked chemistry questions at both the high school and college levels, okay? So if you need some homework help or extra tutoring, please check out the links in the description below. And with that, let's kick it off with our first question for this session. And we are going to be solving this. Okay, give me a quick second just to make sure. So we have, sorry, there we go. There. Write the complete ground state electron configuration ground state electron configuration for scandium, okay, atom. And then B, it's asking us for noble gas shorthand notation. All right, so how do we approach this question? Well, for this, it's always important to just go through our electron configuration rules, which is of how we start. We have 1s, which is going to be for the first row. This is going to be for the second row. The third row will have, well, not technically third row, but the third shell. These are all the possible combinations. And the fourth shell will have, and then the fifth shell, and so on. But because scandium is relatively early, it is a 21st element, we won't have to go that far. So with that being said, let's actually cross 2 to see how far we go. So in each s orbital, it can fit only 2 electrons. P orbital, that's 6 electrons. D is 10 and F is 14. So considering that we're starting from hydrogen and helium, we're counting through the periodic table, okay? We only have this filled out so far. So we have 1s2 because those are filled, okay? And then we move on to lithium, beryllium. That would also be our S shell. The S shell is a first and second column, including helium. And the P shell, as we're going to see, is going to be the columns 13 through 18, not including helium, okay? So now we have 2s2 for the lithium, beryllium. And that means from boron through neon, that would be 2p6. And then for sodium to magnesium, we now have 3s2 completed. And then from aluminum to argon, that would be 3p6. And then we move on now from potassium to calcium, that is 4s2. So now we've done all these. And the scandium, okay, is going to be the 21st element, as we said, as it's going to be touching the d orbital. So we're actually going to circle it as a way of signifying that is where we're leaving off. We have a 3d1, okay, that's for scandium. And for the sake of reorganizing it to keep all the threes or all the orders, the numbers that come in front, the coefficients, we want them to all be going the same order. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. Okay, so this is what we have for scandium, I believe. Yep, that's the element we're dealing with. Okay, so now for the noble gas notation. As we mentioned, all the way to argon, okay, if we were to get the element of argon, we would be stopping at 3p6. So all of this will be the notation for argon. The goal of the noble gas notation is to pretty much, we start from the most recent noble gas and then we work our way back up. So the most recent gas is argon. So we would write it like this, okay? And then we would go back to counting as normal, and we saw that there was a 3D1 for S2. This right here would be our noble gas shorthand for scandium, because you see argon, that's where we were, and then we fill in the rest. And you actually notice that if we counted every superscript, we would actually end up with 21, because that's the 21st element. So we have 1s2, right? So 2 plus 2 plus 6, so that's 10, then 12, then 18, 19, 20, 21. Thus confirmed this is indeed our 21st element. And you'll notice that argon, the 18th element, we have 2, 4, 10, 12, 18. There we go. We used the 18th element, and then we added 19, 20, 21. And that's how we got scandium. So let's see how we did. So exactly, 1s2, 2s, and then it keeps going to 3d1. And, oh, whoops, write the electron configuration of iron. So we did not finish solving this. So we have the noble gas configuration for scandium. So let's actually see what iron would be. So iron is right here, okay? The 26. So instead of at least we solved here, and because we're going to keep it relatively short, we're still going to start with argon, because that is our most recent noble gas. But instead of it being 3d1, we actually have 3d2, 3, 4, 5, 6 on the iron. So it'd be 3d6 and then 4s2. Okay. Personally, I like to write with the coefficient lowest to greatest. Some people just write whichever one is coming up, as in which orbital you're in. But that's how I personally like to write it. But that would be, this would be for iron. Okay. So we have a scandium here. Okay. And as the question was asking, this is for iron. So scandium, yep, we have that. And then iron, this is the longhand notation for S2 3d6, which is what we have at the moment. And then they replace it with argon, and so they have argon for S2 3d6. As I said, I like to keep it with the lowest coefficient first. That's why I have 3d6 for S2. Because that's also how the orbitals will align themselves. It is technically in the third orbital, so it would come technically prior to the fourth orbital, even though it is in the D shell. So this is correct nonetheless. Let's now move on to question number